In this video, we'll be seeing the various states a transaction goes through. You need to understand the various states in order to understand the coming videos and coming topics. So, a transaction, we'll be seeing the phases of a transaction one by one. A transaction begins. You can imagine a transaction to be anything like you are actually trying to transfer an amount from one account to another account, or you are trying to buy something from Amazon, or you are trying to book a seat using Book My Show, or you are trying to book a railway ticket or an airline ticket. All these are transactions. So the transaction begins. The transaction is in an active state when the read and write operations are taking place. That is like you are um, adding things into your cart from Amazon, or you are actually booking a ticket, you are actually transferring an amount to another account, or some amount is coming to your account. So all these are examples of read and write operations taking place. So when as like till all this read and write operation is taking place, we say the transaction is in an active state. So once the operations are over, we say the transaction ends and goes to the partially committed state. Now at this stage, imagine it an example like you are trying to buy something from Amazon. You are okay. You selected all the products you want. Now you are going to the window to make the payment, and you need to enter the OTP. That is the only thing left you need to do to complete your purchase. So at this stage, we can say the transaction is in a partially committed state. Okay, so end transaction, partially committed state. I hope you got that example. Now imagine you were trying to buy something from Amazon, or trying to book a ticket. At that particular moment, you don't feel like buying it, or maybe the current goes off, or the server goes off, or something happens and that window closes. Either you close the window or something happens. So all this can be taken as an example of the transaction being aborted. So if that happens, the transaction is aborted and we reach the failed state. We say the transaction has failed. So hope you got what we mean by abort. So now coming back to the partially committed state. Partially committed means we had considered that just OTP is to be entered. Now imagine you enter the OTP, you have sufficient balance, the amount is being transferred from your account to the vendor's account, and everything goes fine, and we say the transaction is committed. And once this stage is reached, that is the transaction is committed, only then we can say the transaction has terminated or the transaction ends completely. Now even in this partially committed stage, imagine you don't enter the OTP, either the server goes down, or imagine you don't have sufficient balance in your account, so that the amount is not transferred to the vendor, so and the transaction is not successful. So even in this partial committed stage, the transaction can be aborted, and if the transaction is aborted, again it goes back to the failed state and the transaction is terminated. So the transaction can be terminated either by being committed or being a failed transaction. Either ways, the transaction is terminated or the transaction ends. Hope all the stages are clear to you. Transaction begins, read write operations takes place, it is in active state, it ends, it enters the partially committed state. It can either get committed or it can abort and go to fail state. From the active state also it can go be aborted and reach the fail state. Either ways, the transaction would be terminated either by being committed or by being a failed transaction. So these are the various states a transaction can go through. Now one more theory topic we need to look is acid properties. Acid stands for actually A for atomicity, C for consistency, I for isolation, D for durability. So every transaction or a database should actually satisfy these four properties. That is what they say. They should every database should satisfy acid properties. And let's have a brief on what each of the term is. So atomicity means a transaction is an atomic unit, like it's a single unit of processing, and it should either be performed in in its entirety or not performed at all. That is, like take this case, we begin a transaction, either it should reach the committed stage or it should be aborted. There's nothing that like a transaction remains in the partially committed state for long. Either it would be committed or it would be aborted. So once it starts, it has to be performed in an entire manner, or it should not be performed at all. So that is what we mean by atomicity. Consistency, isolation are somewhat similar. Consistency means like a transaction should be consistency preserving, which means if it is completely executed if it is completely executed from beginning to end without interference from other transaction, it should take the database from one consistent state to another. Like you are trying to transfer 1000 rupees from one account to another account. If all things go fine, the consistent state would be like initially you had 5000 rupees, 1000 rupees is getting deducted, and finally you will be having 4000 rupees, and the one to whom you are transferring would have say plus 1000 rupees to his account. So this so you are being taken from one consistent state to another consistent state if all the things goes fine. So that is consistency preserving. Next term is isolation. Isolation is like say when you are trying to purchase something from Amazon, do you feel like other people are also trying to purchase something? No, you get a feel like you are the only user using that particular application. So you get that feel. So that is actually isolation property. A transaction should appear as though it is being executed in isolation from other transaction, even though many transactions are executing concurrently. So this should be also satisfied by the database. The final property is durability, which means like you make changes, like the changes applied to the database by a committed transaction must persist in the database. These changes must not be lost because of any failure. Say you transfer 1000 rupees from your account to another account and everything goes fine. Now even if the bank server goes down after the transaction, when it comes back, the already committed transactions should be there as it is. So already committed transactions should be consistent and it should persist till the end. So that is the durability property. It's not like you did a transaction and it was committed, even it was committed, and later maybe the next day the bank server went down, and it's not like all the previous transactions have vanished. No, it is not like that. So that should not occur, and that database should preserve durability property. Now the rest of the module will be seeing how all these things are achieved. Like in the previous video we saw what are the different issues that can occur, and in this video we saw what are the different properties a database should satisfy. So in the coming videos we will be seeing solutions using which these properties are satisfied, how the previous issues addressed in the previous video don't occur. All this would be seen in the coming videos. So that's all for this session. Thank you.